The last objective for our first standard is I can solve a system of linear equations by elimination. You may want to pause the video so that you can fill in the blanks for these steps. So for elimination, you want to make sure that all of the variables are lined up one on top of the other, and look for the same number in front of the same variable, but with opposite signs. Those are called inverse coefficients. If you can't find some, then you're going to make some by multiplying one or both of the equations. Once you've found your inverse coefficients, you're going to add the two equations together, which would eliminate the variable that had the inverse coefficients, and then solve for the remaining variable. Use that value to find the other variable's value, and then of course write your answer as a point. Let's go ahead and see that in action. So we have our first system here, and again I gave you guys kind of what I like to call training wheels to help get you started. We have our first equation, 3x plus 6y equals 0, and then negative 5x minus 5y equals negative 10. And we want for our variables to cancel out, or at least one of them, either x or y. And to do that, we need to decide on a variable and then figure out what number do both of those coefficients go into. So if I want to cancel out my y's in this case, I need to look at 5 and 6 and decide what number do both 5 and 6 go into. And that would be 30. If I wanted to cancel out my x's, I would need to look at 5 and 3 and decide what number do both of those go into. And that would be 15. If you can't think of a number that both of them go into, you can always just multiply the bottom equation by the coefficient from the top and the top equation by the coefficient from the bottom. Sometimes that will end up giving you the smallest number that they'll both go into, and sometimes that'll end up just giving you a number that they both go into, meaning you'll have to deal with bigger numbers, but you'll still be able to eliminate. I'm going to choose to eliminate my x's in this, so that means I'm going to multiply my top equation by 5, and I'm going to multiply my bottom equation by 3. And I already have opposite signs, so I don't need to make one of the things that I'm multiplying by negative. So when I multiply 3x times 5, I get 15x. 6y times 5 gives me 30y. 0 times 5 gives me 0. And on the bottom, negative 5x times 3 gives me negative 15x. Negative 5y times 3 gives me negative 15y. And negative 10 times 3 gives me negative 30. Now the whole goal there was for me to be able to cancel out or eliminate my x's, which leaves me to solve for y. So when I go and add these two together, I am able to cancel them out because 15x plus negative 15x is 0. 30y plus negative 15y gives me positive 15y. 0 plus negative 30 gives me negative 30. Then we need to divide by 15 on both sides so that we can solve for y. So negative 2 is part of my solution. And on our last step, we are going to substitute that y value so that we could solve for our x value. Now, pick either equation, either the blue one or the pink one. It does not matter which one you choose. But you're going to substitute negative 2 in for y. So I'm going to choose the pink equation. So I have 3 times x plus 6 times, and here's where I'm substituting in my -2 for y, equals 0. 3 times x gives me 3x. 6 times -2 gives me -12, equals 0. Add my 12 to both sides, and I get 3x equals 12. Divide by 3, and x is equal to 4. So my solution is 4, -2. Let's take a look at the next problem. I'm going to go ahead and type in, or write in, rather, my equations. And decide which one I want to be able to cancel. I'm going to choose in this one to go ahead and get the y's to cancel. So that would mean I need to find a number that both 3 and 4 go into. 12. So I would need to multiply the top by 3 and the bottom by 4. And if I want them to have opposite signs, I either need to multiply each of the top equation by -3 or each of the bottom equation by -4. So I'm going to go ahead and make the top negative. So that will give me across the top. -3 times 5 gives me -15x. -3 times 4 gives me -12y. -3 times 9 gives me -27. For the bottom, 4 times 3x gives me 12x. 3y times 4 gives me 12y. 9 times 4 gives me 36. Time for us to go and add the two together. And our goal here was to get the y's to eliminate so that we'll be solving for the x's. -15x plus 12x gives me -3x. -12y plus 12y cancels just like I wanted. And -27 plus 36 gives me 9. Divide both sides by -3, and x is equal to -3. So now we'll be substituting our x value in so that we can solve for our y value. Does not matter which equation you choose. Last time I used the pink equation, so this time I'll use the blue equation. 3 times our x value of -3 plus 3 times our y value equals 9. 3 times -3 gives me -9 plus 3 times y is 3y equals 9. Add 9 to both sides, and 3y equals 18. Divide by 3 on both sides, and y is equal to 6. Let's take a look at our last example on this page. In this example, we're going to go ahead and put our information into the setup. Pay close attention though, because our x's and y's are not already lined up for us. That's why we have this step, so that we can make sure that they are lined up. So 9y, negative 3x, and 6, negative 5x, 15y, and 0. Guess I made them both pink, oh well. We want to decide which one we're going to cancel. It doesn't matter which one. We'll be dealing with smaller numbers if we get the x's to cancel, so that's what I'm going to do. So we are going to multiply the top by 5 because 3 and 5 both go into 15, which means the bottom will need to be multiplied by 3. Now I don't already have a setup where they're opposite signs, so I need to make one of these multipliers negative. When I do that, I have negative 5 times negative 3x gives me positive 15x. Negative 5 times 9y gives me negative 45y. Negative 5 times 6 gives me negative 30. And for the second one, we have 3 times negative 5y gives me negative 15x. 15y times 3 gives me 45y. And 0 times 3 is still 0. Our goal was for us to eliminate our x's so that we could solve for y. So we'll add them up. 15x plus negative 15x cancels just like we wanted it to. Negative 45y plus 45y, that also cancels, which leaves us nothing on the left. Negative 30 plus 0 gives me negative 30. So since they add together and create a false statement, our solution should be that there is no solution. Think back to the chart that we filled out when we're solving algebraically. It holds true for substitution and elimination because those are our two algebraic methods. When we have a false statement with no variables, our answer is no solution. And if we were left with a true statement with no variables, our solution would have been infinitely many solutions. Let's go ahead and apply this to a word problem. Suppose your class sells gift wrap for $4 per package and greeting cards for $10 per package. Your class sells 205 packages in all and receives a total of $1,084. Find the number of packages of gift wrap and the number of packages of greeting cards sold. Just like when we were doing substitution, your first step is to identify your let statements. What is X going to stand for? What is Y going to stand for? Those come from the question that they're asking you. How many packages of greeting cards and how many packages of gift wrap? So I'm going to assign gift wrap to be my X. Which means that the number of packages of greeting cards will be my Y. Next, go ahead and take a look at your problem and see if you can separate it out into two categories of information that they've given you. One category that's pretty prevalent in our story problems is money. They give us information about how much each of the different kinds of packages cost and how much money they raise total. So there's gift wrap for $4 per package and greeting cards are $10 a package and they raise a total of $1,084. The other kind of information that they give us is how many total different packages they have. So let's focus on the money first. If I take $4 and multiply it by the number of packages of gift wrap, I would have the total amount of money that I'm spending in or that I'm raising in gift wrap. Add to that the $10 times the number of packages of greeting cards, and we would have the total amount of money that was raised from the gift wrap and greeting cards. Let's take a look at the next bit of information that they gave us, which was how many different kinds of packages there are. So if X is the number of packages of gift wrap, and Y is the number of packages of greeting cards, and we know that there are 205 packages in all, we can add those two together to equal the 205. The next step is to make sure that you have written your equations so that your variables are lined up, which mine are, so I get to skip this step. Determine which variable you would like to eliminate. I'm going to choose to eliminate the x because I'd only have to multiply everything by 4, which would mean I'm dealing with smaller numbers. But you could have multiplied everything on the bottom by 10 so that you were dealing with easier numbers to multiply. It doesn't really matter. So I'm going to eliminate the x value. So if I want them to eliminate, that means I need to do a little multiplication. My pink equation will be able to stay exactly as it is. And my blue equation is going to have to be multiplied. In order for it to get the opposite, it will need to be multiplied by a negative. And in order to make it be the same number in front, we're going to have to multiply by -4. Be sure that you are multiplying each of the individual pieces. So a total of 3 times we're multiplying by -4. Once we do that, of course, our pink equation is going to stay the same. But our blue equation will become -4x, -4y, and -4 times 205 equals -820. And just like we were doing when they gave us the system, we are adding the two of them together. So our x's really do cancel, and our y's become 6y. 1,084 minus 820 gives you 264. Divide both sides by 6, and y equals 44, and that is packages of greeting cards. Remember, with word problems, we do not write them as a point because they actually have a meaning. So I know that part of my solution will be that there are 44 packages of greeting cards. In order to figure out how many packages of gift wrap, I'm going to go back to one of my original problems. This one doesn't have as many coefficients in front, so that's the one that I'm going to choose to use. And we are solving for x and plugging in our y value that we just found. So x plus 44 equals 205. To solve it, we would subtract 44 from both sides, which gives us 161 packages of gift wrap. So my final solution is there are 161 packages of gift wrap and 44 packages of greeting cards.